few of the students and everybody over the age of 50 just raised their hand. That's okay. But our students are going to be the ones that you'll be watching very soon. And then just to compare the weather app and the TV broadcast to the National Weather Service website, we'll see how functional data is. All right, and what kind of decisions do you make on a day-to-day basis based on weather information? What to wear?
Bring an umbrella.
Do I need to bring an umbrella?
Can we play our games?
Can we play? Okay, now we're getting a little deeper, right? Can we play our games from the athletics department, especially the outdoor ones, right?
How much time do I need to travel?
How much time will it take me to get where I'm going? All right. Those are some pretty basic decisions you have to make. I put some of this together on Wednesday night. Wednesday night we were expecting some sleet overnight, and I opened up the weather app on my phone, and I got that. So the question I have for you is, and I found out if I scrolled a little bit, I could get past 7 o'clock at night. So because I don't use the weather app. So, but anyway, yeah, it says today 50% chance of something in that graphic. Can everybody see that graphic there? Yeah, and Thursday there's 80% chance of something there. Can you determine that there was a chance of sleet or freezing rain on that night? No. So, and then I also just looked at what the forecast was for Friday from Wednesday, and it had a 40% chance of showers. And I don't know, how was the weather for you guys yesterday? Was it 40% chance of showers yesterday? No, probably not. Anyway. Okay, so let's think, is that useful? Could you have made your decisions about what to wear or whether to bring an umbrella? Could you have made your decisions about whether you're going to play a game or not from that?
Get a rough idea.
Yeah, maybe not. Maybe not. Okay, I'm going to embarrass Charlie Peachy, but he's not here. He gave the TV weather broadcast. Oh no. I'm going to forward it a little bit.
It's going to bring us a winter mix Wednesday night into Thursday. We'll go into it in just a minute. But that's nothing we have to worry about today, as the majority of that rain is going to push on through Wednesday night later tonight. And we can see a little bit of a winter mix in some parts of the northern country and in Plymouth, but it's going to be the majority rain, I believe, for the most of the storm tonight. And then as we move into the later forecast periods, we can see that there's a few shots of that mixing winter mix precip to move into our area, but the majority of the rain is actually going to come on through our area around the mid to late afternoon.
Okay, enough embarrassing Charlie. These are our students, right? They're practicing, they're learning how to be TV meteorologists. So again, if you were trying to figure out what to wear or whether to bring an umbrella, did the TV weather broadcast, was it functional, useful information? Did the words sleet and freezing rain actually appear? Right, so you maybe gained a little more knowledge that way. I tried actually getting the WMUR forecast, but they've got their site locked down, so I couldn't steal that. But anyway, that's TV weather broadcast. And no, we need to go past that. And if you go to the National Weather Service, I mean, your tax dollars at work, you can put in the zip code for Plymouth, and up pops this page. How does that? So all the meteorology students are like, But I want to look to other people, right? Is there too much information on that page right away? No, okay, but you can break it down and you can look, right? There's similar to your 7-day graphic, and there was at least some indication that there would be a chance of wintry mix on Wednesday night. And you can still see the Friday forecast was a little bit off. But that sort of gives you the highs and lows and day and night periods. If you scroll down a little further, you can find more detailed information, text format. You know, all us over 50 people, we like that. Again, if you just read that night, a chance of rain, snow, and sleet before midnight. Then, a chance of sleet between midnight and 2. Cloudy, with a low around 30. Chance of precip 40%. New precipitation amounts less than 1/10 of an inch. Somewhat useful, maybe. And again, you know, you can get a little more information that way. And then last, I know one certain faculty member here loves this page. And this is the hourly weather forecast in a graphic format, which is great, chock full of information. I bet if anybody from the public really clicked on that, they'd be like clicking out of that page so fast, right? Because what the heck is going on in that second panel there? I don't know, right? It turns out it's winds, but who knows how to actually interpret that information? There is some useful stuff here about when it's going to rain and what the chances are, but you gotta dig deep to figure that out. Perhaps that would be useful for planning. I don't know. Anyway, that's just an example of a website that you can click and get forecast information. So, all right, not meteorology students. Is the information you receive from a public weather forecast useful for making the decisions you want to make?
Yes.
You are a meteorology professor. Your opinion does not count in this, Sam. Sorry. Okay. The other person with a PhD just to your right, left, gave me one of these. Yeah, right? Can that information be useful? Sometimes it can. If you ask a simple question, right? Do I need to bring a coat? Is it going to rain? That's a simple question that can be answered. But if you ask more detailed questions like, do I have to move my game a couple hours earlier or later? Do I have to worry about my buses driving to Boston and what time they're going? That maybe isn't the information you really want to use. So, there is no actual definition of functional meteorology. And so I've sort of come up with a working definition of my own. And that is, meteorological weather data and information becomes functional when it is useful for making decisions. So functional meteorology will help the person that needs to use weather information make the decision that's going to support whatever they're trying to do. So that's sort of my approach to the rest of the talk. And what I want to do now is talk a little bit about meteorology as a science and the kinds of data that we have, and then talk about some specifics of functional meteorology or decision support. And it's interesting because about 10 years ago, the National Weather Service started going in this direction. And they actually have a document that came out in 2013 that listed Impact Decision Support Services, or IDSS, as a central part of the National Weather Service's mission. So they are moving in a direction of functional meteorology, in that the meteorology that they are trying to do and the data they're trying to give is supposed to help you make decisions. And it's a central part of their logo is a weather-ready nation. So. And if you go on the internet, you can find a document called their Roadmap to a Weather-Ready Nation, version 2. And I've highlighted in some of the text I took out of their document. This is the service section. There's a lot in there. But there is a couple of things I wanted to highlight. So a shift from product-focused services to something else. And what they're trying to do is to support a response to local and regional high impact events, right? So they're going to try and focus on what high impact events. And they're trying to support good decision making and planning. and we're going to circle back around to this. But you can see that the federal government and the National Weather Service is already moving toward having more of a functional meteorology approach. Okay, so let's ask this question. Are meteorologists trained to provide decision support services? And what research have we been doing at Plymouth State that has made better use, that has enabled people to use weather data and information better? All right, so we're gonna sort of think about, okay, what are meteorologists trained to do? What is the science of meteorology? Can we actually use that to make decisions? I think the students are here like, yeah, we can, I can see it, yeah. All right, so, all right, students, here's your chance. What do we learn in meteorology? Weather, I got weather. Let's boil it down some. No, that is, the term that they said was frontogenesis. That is not boiling it down at all.
How about latent heat?
How about physics? How about physics, right? Meteorology is about physics, and while meteorology isn't rocket science, you can't use physics to do rocket science, so yeah, I guess meteorology is rocket science, right? So we need to know how the physical mechanisms that drive the weather work. Need to do a little math, because the mathematical descriptions of the physics is what drives our science. These are my two favorite equations, and this is actually taken from class in Dr. Avilas' class this week. So several of you should know what's going on here. It'll be on a test coming soon. Yeah. The science of meteorology is described by calculus. And plus we need to know some statistics in order to make things useful. So, gotta know a little math. Physical geography. You gotta know where the mountains are. And you gotta know if there's an ocean next to you or not. And if the wind's coming from the mountains or the wind's coming from the ocean, it's gonna change your forecasts, right? It's gonna change the weather data and information. So, we need to know, as meteorologists, how the Earth is working as well. And you put it all together, and meteorology is really a multidisciplinary field of sciences. And this is a graphic that shows what a climate model needs to do, all the things a climate model needs to take care of. But it's the same for a weather model, right? So meteorology is an Earth system science where we focus on the atmosphere. But we can't ignore, let's say, the ice cover over the poles or where the snow is currently. We can't ignore the oceans. We better know where the warm ocean currents are and the cold ocean currents are. So it's a very complicated system that we have, and meteorologists need to use that information of all these sciences to produce weather data and information. Maybe, if we do it right, it'll be useful. We'll see. What I wanted to go to next was just to take you through some simple next steps. So away from a public forecast, 30% chance of partly cloudy and a shower or two, right? That's at least not very useful. All right, can anybody think of a sector that needs sort of more detailed and specific meteorology information?
Airports.
Airports, Justin. Thank you. I did not plant that. So yeah, I mean, aviation is an industry that clearly needs detailed meteorological information, and it needs it to be useful, so that you don't try to land an airplane almost sideways to the runway, or that you avoid icing or really dense fog. And so for meteorologists, right, they have to get away from the public forecast of 30% chance of showers. Now, if they're talking to pilots or to people that are routing airplanes or doing aviation meteorology, they have a very specific audience. and they need to be able to make that information useful or functional to them. So just as an aside, right, some things you need to know as an aviation meteorologist is how airplanes work and what kind of airplanes are flying out there. The difference between the airplanes that land at Plymouth, K1P1, the Plymouth airport, and the ones that land at Logan, there are different kinds of airplanes. They require different operating parameters. You need to know a little bit about airport operations. You need to know a little bit about air traffic. The critical forecast elements to make your forecast useful are to be able to identify aircraft weather hazards, such as icing, low visibility and fog. It's kind of hard to land the airplane if you can't see the runway, right? Turbulence, others. There's plenty of others. And so as meteorologists, we have to use our knowledge of the atmosphere to provide transportation support to the aviation sector. And we've been doing that lots here. One of our alumni is the meteorologist in charge at the Central Weather Service Unit at the Nashua Air Traffic Control Center. And we've had dozens of students doing research projects and internships over the years. And one of the things that they've researched in order to help make better decisions is sea breezes. Dr. Miller and company have done that. And that helps them understand when the planes are landing, which runway to use. And it's actually really critical in Logan because when the sea breeze kicks in, it's bad for air traffic at Logan. So that's one thing we've been doing. Okay, so if we take it transportation, the next level away from aviation, we still need to make some useful forecasts, but we're still in the meteorology world pretty much. What's the next transportation sector that might need specific meteorology forecasts? Ships, oh yeah, no, I went the other way.
Trains?
No, not trains, but yes. Roads, yes! Now this is, you get a little intersection with a public forecast here, right? Because you said you gotta know where, where, somebody said where they're gonna drive to, right? John in the back. Right, so we have to look at specific forecasts for roads, and it's interesting because there is no agency responsible for road weather forecasting. And so it's kind of left to the public. You get in the car or your plow truck and it's up to you. But interestingly, winter weather maintenance decisions are a very specific decision support, right? When should I go out and plow the roads? How much salt do I need to put in the back of the truck? Will the salt work, right? And when should I go and do that? And it's cost state departments of transportation millions of dollars on those decisions. So these are important decisions to make, and we need to make sure that our weather data is functional for them. So if we think about what else a meteorologist needs to know to support decisions about winter road maintenance, you gotta know something about pavement temperature. That's not meteorology, right? But when the roads are frozen and cold, it's different than this time of year, right? It snows this time of year. We got a snow the other day, right? The roads were fine. But that's because the pavement temperature had already come up. You need to know a little bit about the chemicals that are used in road treatments and when they're effective and how they're effective. Now you're looking at a different set of forecast elements, right? You're not, visibility is still an issue, but certainly turbulence isn't. But you need to know, what are the amounts of frozen precipitation? What are going to be the onset times and the ending times, right? If you are going to pre-treat the roads, you need to get out there a few hours, but not more than a few hours before the precipitation starts. So that's a very critical decision that 30% chance of showers does not give you, right? So we need to provide decision support for those kinds of decisions. Obviously, precipitation type and the location and timing of any difference changes between those, and that's a whole other ballgame in terms of supporting those decisions. Over the years, Plymouth State has partnered with the New Hampshire DOT. We helped them install the Road Weather Information System, which is a series of weather stations up and down the highways. If you drive by every once in a while, look at the little white towers by the side of the road. Those are weather stations. And we helped figure out where to put them for maximum use, and we still have that data, and we've had several students work on that. Okay, lots of other research has happened at Plymouth State that has supported decisions and made meteorology functional. Here's just a sampler. Dr. Cordera and his students have looked into atmospheric rivers, and they actually support reservoir operations in the West. How much water should we let out or hold back in a reservoir? Looking at flash flooding and debris flows, right? What is the relationship to those? And ice jams. I think we're all a little familiar now at Plymouth with ice jams and ice jam flooding. So those are critical decisions that need meteorological support. Air quality. Dr. Avilas and students have looked at forecasting for ozone and particulate matter and across the state, and developed some new methods for looking at those forecasts. We had the good luck of having a field experiment here about 15 years ago. There was a boat driving around in the Gulf of Maine, making air quality measurements. Who told them where to go? We did, right? Because they did not want to go into clouds. They wanted to stay, and it was summer, and it's fog in the Gulf of Maine, and they did not want to go into the fog to make their measurements. So we had to provide very specific decision support for that field experiment. Winds. Winds are a pretty critical forecast element. If you're out in the Gulf of Maine enjoying a nice sail, Dr. Miller and folks investigated some unusual circumstances of unexpected high winds in the Gulf of Maine. Former colleague, Dr. Kermer, he actually investigated convective winds, that's winds from thunderstorms that affected launches at Cape Canaveral. And again, these are very specific decision support, but it's all so far meteorology. And then recently we've had some students working with the Weather Service, one of which investigated the use of the term heavy rain by the meteorologist. And this is starting to get into the multidisciplinary approach, right? So when do we use the word heavy rain? What does that mean to the forecasters? How is it functional for the public? And right now I have a student that's working on impacts from storms that transition from tropical to extratropical as they move up through New England, and the special kinds of weather that those can produce. So those are all just other examples of research that's been done here at Plymouth State that has helped meteorological data and using a multidisciplinary approach, mostly from the science of meteorology. Okay, I want to give you a quick overview of one of the stuff that I have worked on over the years. And I want to sort of give you the arc of the research so that you can see that it, hopefully we improved on our decision making a little bit, or at least learned some important lessons. Power outages. Weather knocks out power. In the early 2000s, PSNH, which is Eversource was called PSNH back in the day, came and said, hey, weather knocks out our power. We don't know exactly what kind of weather knocks out our power. And I said, I can do that. Or my students can do that. We got a set of power outage data from them, and we started investigating what kind of weather knocks out power. And we did an initial climatology, which was to say, okay, here's when more than 100 customers were out of power, here's what the weather was. And then we developed some, situational awareness. Okay, this kind of storm is the usual kind of storm that knocks out power. It could be a windstorm or a winter storm. Turns out, your big heavy snowfall events, 2 feet, somebody mentioned the 2 feet, 27 inches in 9 hours overnight, and I had to walk from my house to Boyd. 2 feet of snow, the power was great, right? The big heavy snow is often not the ones that knock out the power. It turns out wet heavy snow is a problem, and high winds are a problem. And so we came up with some, guidance for situational awareness for PSNH. You can see the little decision tree here, and then we built them a website where they could click around and find from the web, maybe I should be paying attention to that. And they were pretty happy with that. Okay, good. Also, millions of dollars for them, hundreds of thousands, because they need to position their trucks like where they think the power outage is going to be. New Hampshire, it turns out, in the north-south direction is kind of a big state. So if they want to position their trucks up north of the notch, that costs them money. And if they need to move resources to the southern part of the state, that costs them money. And so they were trying to use this tool to do that. Well, a few years later, they came back and they said, well, Eric, that's really nice. We use the tool. It tells us, the storms are coming and we know we need to do something. But we want to know where to put our trucks, like the day before. And we need to know, does it have to be in Claremont or does it have to be in Concord, right? That's the kind of level of detail they were looking for. And a student and I decided, we can do that. Give us some more power outage data, and we'll compare it to the weather data at weather stations. So like, if the weather at Concord is this, all the power outages in Concord are compared to that weather data, then we can make a prediction and build a predictive tool using statistical methods. So this is still within the framework of inside the multidisciplinary of meteorology, right? So we applied some statistical forecast techniques. This is called a regression tree. The side here is not really important. Just know that the blue is the forecast and the red are the actual. And I think you can see they don't line up. And that turns out, that some of our assumptions were a little bit flawed, and it was sort of not the best approach to take, to use individual weather station data, because the outages are occurring in places that are not where the weather stations are, and so you can't directly make a one-to-one saying the weather at Concord is going to be what knocked the power out in Kentucky, right? Ooh, I showed some New Hampshire geography knowledge there. All right. So they were still interested in that. And a few years later, I was able to get together with some colleagues at the University of Connecticut. And the folks at the University of Connecticut were in an environmental engineering department. And they built a predictive model. And we began a collaboration that was both interdisciplinary and collaborative to solve problems. I had a couple more students working on some of the data. They were especially interested. They built their model to work in Connecticut. Physical geography. What's Connecticut like? Flat and close to the ocean, right? What's the physical geography of New Hampshire like? Not flat. Not flat. So one of the things we were trying to do was to assist them with building out their model into New Hampshire. And so the approach they took was actually computer science, numerical weather prediction model, making a forecast over a wide area, and driving statistical analysis of that model data against power outages in a nonlinear way. This fancy math, that's all that is. But another critical thing that they did was they worked with GIS and their power line group, and they actually mapped every mile of power line in GIS and saw how close the trees were to the power lines and measured how the tree coverage in the vicinity of the power lines. So that's in their prediction model. So that was kind of new, right? Somebody had to go out and know how to do the GIS and learn, okay, what about tree growth? And how fast do the trees grow back? And what assumptions can you make about that if you've got aerial imagery that's old? And we brought in, from our side, some knowledge of winter weather. Connecticut doesn't get the same kind of winter weather we do. It's close, but it's a little warmer down there. And we brought some knowledge about modeling and forecasting in complex terrain. So that sort of gives you a hint of where things are going. That prediction model will actually tell you exactly how many outages to expect. It's not perfect. It's pretty good at giving you the size range of things. So there's still work to do here. But I think, going from simple meteorology, here's where the storms were when the powers were out, to some statistical modeling, here's the statistics when the power was out, to really interdisciplinary collaborative work where we can say with more certainty what the prediction of outages is. I think it's the way things are going. Okay, so almost time to wrap up. I see everybody's eyes are glazing over, so I'm gonna try and get out of here. I really think functional meteorology, in order to make decisions, we are going to need to be interdisciplinary and collaborative, right? The decisions that people are asking of meteorology data now are way different than they were when I started 30 years ago, right? They're asking harder questions. So Kip, yours was, can we play the game, right? The next thing you're gonna ask me one of these days is, can we play the game at 3:15 or should we push it to 3:45, right? So that's a different kind of question, and that's where we're headed. In terms of science collaboration, we meteorologists are going to be collaborating with engineers. We're going to be collaborating with environmental scientists. We need to know something about big data. And AI, artificial intelligence, is huge in our field right now. So that's where we're headed. And I hope to impress on you that we're going to need to talk to some other people. Social scientists and people who understand communications are important because we can no longer just hand people a forecast and say, here it is, you do what you want with it. Part of our job to make meteorology functional is to give people a forecast and help them understand it. Communicate with them that important information. So that's where we're headed, and I'm going to prove it to you. So back to the NWS roadmap, right? I had highlighted these phrases here, all right? I'm going to highlight some other phrases that were in this document that's now almost 10 years old. Shift to interpretation and consultation, right? That's not meteorology. That's interpreting our meteorology and consulting with people, humans. Communicate. Communicate. Forecast confidence information. So how confident are we in our forecasts so that decision makers can use that information? Deliver information in a way that conveys its potential impact, right? Its potential impact. That's important, right? And so we can't just go, here you go, 30% chance of showers, see ya, enjoy, make your decision, right? What is going to be the potential impact? Partner with people to improve communications and dissemination for high impact events. All right, I'm going to prove it to you. All right, who knows the difference between a watch, warning, and advisory? I am looking at the people who are not in meteorology. You look it up every time. Right. So the Weather Service is actually actively working on revamping watches, warnings, and advisories because guess what? They did some research with social scientists and they found out nobody knows what they're talking about. Nobody knows the difference between a watch, a warning, and an advisory. And they worked with social scientists to survey people to figure that out. So they are right now figuring out how they're going to move from watch, warning, and advisory to plain language. That's so obvious, right? Plain language warnings, plain language statements. And they are making these moves as we speak right now. So in the past, they would have put out a statement that said, wind advisory in effect. Ethan, do you know what the criteria for a wind advisory? He's a meteorology student. I'm sorry to pick on you. Kind of, but not really. So what hope does anybody else have, right? If we don't know it. I can't tell you what the criteria are for a wind advisory. All right, move that to windy. Westerly winds gusting to 40 miles an hour. Coastal flooding advisory in effect. Okay, nice. How about caution, coastal flooding expected today, right? That's a better warning. Wind chill advisory, very cold tonight, right? Wind chills between -5 and -10. That's an effective message, right? And so I think one of the ways that we are going to make meteorological data more functional and useful is working with our social scientists to figure out how to give that information in a way that is received correctly, and the Weather Service is already working on that. Okay, so I'm going to wrap it up. For me, functional meteorology is about making weather and climate data and information useful for decision making. That's how I would like to define it. This requires tailoring information to specific users. So we can't just throw out that 30% chance of showers anymore, right? We have to tell people what that means for them. And the future and present decision supports are going to require interdisciplinary collaboration, communication, social science. We're humans. We have to talk to each other. And so I think we need to make that happen. Couple of acknowledgements. First off, my family. My parents put up with me as a young child, being the nerdy guy that's told them at 10 years old that he was going to study meteorology. They went, okay. But they supported me. Thanks to them. My wife, Darcy, she's in the audience. She put up with me in grad school. Enough said. And supported me there. My kids, Jared and Leah, they keep me honest. They insist I give them the 30-second explanation, not the 40-minute one I just gave, and they're important. Colleagues and friends, many of you are here in the audience. Thank you for being there, for encouraging me, and helping me become a better professor and a better scientist. Students, it's about you guys, honestly. So thank you very much for being there, putting up with me. And learning a thing or two, and hopefully it's a journey we take together. And the students that have worked with me in the past are really important. And certainly, the most important person to thank today is Colonel Souza. Your support for Plymouth State University and the meteorology program is very much appreciated, and we thank you very much. So I am going to stop there. There's where all the places I stole stuff off the internet. And I ended the slideshow. I'm going to leave the conclusion slide up and take questions. Are there any questions? Kim? Oh, wait, Kim. I'll repeat the question.
I'll do it.
I got it. We're trying to get the mic so that anybody online might be able to hear you, if you don't mind.
So it's kind of a silly question. It might be a silly question, but I'm really curious. So when we do watch the weather people on TV, are they the ones who have concluded what the weather's going to be? Have they done the research themselves? Or is somebody else doing that and they're reporting it on TV?
It depends. The people who call themselves meteorologists on television will have made their own forecasts and have interpreted the data and are giving it to you. There are other people who are weather broadcasters that might not have a degree in meteorology and are using information that's been handed to them. So on TV around here, they're all meteorologists. So you can rest assured that they've taken a look at that weather data. They may have gotten some assist from someplace else, a forecast service, but they are putting their interpretation on that using their meteorological knowledge.
Thank you.
You're welcome. Okay.
So I guess I don't really have a question, just a comment, and I wonder what you think about this. So I think it's really interesting who you think you're going to need to collaborate with in the future. I wonder what you think about psychologists as part of it, because it seems like communication isn't enough. You need to actually understand how to change people's behavior in response to whatever you're asking of them.
So I guess social science is very broad, and I guess I would include psychology in
I
that.
think they call themselves a science.
I'm really happy that you're a psychologist in the audience today. So absolutely, right? We're asking people to take action, especially like when there's imminent dangerous weather, and we need to do that effectively. So yes, not only what is the message, but how are people receiving the message and what actions are they taking? And that's an active area of the field right now. So we are working with social scientists, psychologists, and people who study communications and how that affects people's actions, right? When the tornado siren goes off here in Plymouth, okay, there was a laugh from up front here, right? I'm gonna tell you, 75% of the people here will not know what to do, right? Because it's so infrequent. And so how do we effectively make that message here? Whereas in a place like Illinois or Texas or Oklahoma, they know what to do when the tornado siren goes off, right? So we have to figure out how to make that message stick for everybody. Very clustery. Very clustery. Yes.
Colonel Souza has a question.
Colonel Souza.
I just have a simple question. You didn't mention people with money, the business people, in your list of people that you interact with on that list. You talk about social scientists. Because they're going to be the ones who are going to decide whether or not you're just going to ingest data and they're going to use an algorithm to decide, to do the decision, or they're going to use a person to help with that decision. Any thoughts on those dichotomies of whether it's going to be a person or a machine making that decision?
Ooh, so there were two bits in there. I didn't include business in the people we need to collaborate with, and I guess that was a bit of an oversight. I definitely believe we have to work with business folks to understand impacts on their business and how we can make decision supports for them. M&M Mars hires meteorologists to, among other things, predict futures for peanuts and cocoa and all the things they need to make their candy. But they also, there's a story out there that they actually also figure out when cold fronts are going through so they don't have to ship using refrigerated trucks. So that's one thing. And then the other question you asked, which was really good, is about algorithms and AI. And is there a role for meteorologists, even in the business world? And I think yes, both in the public square and in the business world, we are that communication, making the support functional is going to require decisions made by humans. And so we need humans to interpret what the machines are doing, to know what the machines are doing, and then to interpret that information and provide that to the people that are making the decisions. So I do not see us losing out entirely to the robots. To be fair, the robot forecasters are getting really good. So we got to have to make sure that we provide that decision support.
I'm going to ask the question.
Yeah.
The meteorology program as it is currently built includes many interdisciplinary and similar disciplinary curricula. Computer science, for example, all the mathematics classes. You teach a course in transportation meteorology. What changes might you envision over the next 5 to 10 years to introduce more elements of functional meteorology into the program?
It should be a softball, right? It's a time to talk about the cluster approach to education, right? And interdisciplinarity and project-based learning. And so the answer is, as the field evolves, so too does our curriculum. And I think taking an approach that students will get more of that kind of classwork We're stepping off the cliff now and doing a good job, and that'll be part of their gen ed program from here on out. But I think, incorporating that kind of thinking into our coursework, onto our syllabi, to help students realize that, okay, now you just made a forecast. We made some forecasts this week in class, right? How functional were they? Did we talk about them being functional? No, so we need to move that way. And so I think we'll probably have to look at our syllabi and figure out where we can make those changes to help the students, be ready to participate in that kind of stuff. You know what, I'm gonna call it. And anybody else who has more questions, please come see me. I'm happy to talk about it. Thank you very much for coming out on a Saturday afternoon. I very much appreciate it.